All right, so this is 5-3 bisectors in triangles. So we're cutting stuff in half. The learning objective is to identify properties of perpendicular bisectors and angle bisectors. So last section we were using properties. This time we're identifying properties. There's two basic topics that we're looking at. And we're looking at when you cut all the angles in your triangle in half and where they meet. And then we're looking at all the perpendicular bisectors. So it's where you take the side, cut it in half, and the one that goes 90 degrees. And true or false, construction-wise, we have cut angles in half before. True, we've done angle bisectors. And we've cut line segments in half before. So, asking you to create a triangle or given a triangle, cutting all the angles in half and then finding where they intersect is a viable paper activity for you. Okay. So let's look at the definitions. The point of concurrency of the, which means where they cross, of a perpendicular bisector of a triangle is called the circumcenter. So where your perpendicular bisectors cross is called a circumcenter. So I would definitely make flashcards for this, because knowing the difference between a circumcenter and an incenter is going to be very important because the two are different. So a circumcenter is the perpendicular bisectors. A circle is circumscribed about a triangle if it looks like this, where the circumcenter is the center point of your circle. Now, thinking of this in terms of construction, you find all the perpendicular bisectors, find where they cross, and then using that as your center point and opening your compass from point P to point C and making a circle circumscribed about is a valid geometry option. This is kind of it's not as important, but it's important to note. The point at which, when three or more lines intersect at one point, they're concurrent. The point at which they intersect is the point of concurrency, since we're using the word concurrent in our previous definitions, kind of important to know where that comes from. All right, so concurrency of perpendicular bisectors theorem. Perpendicular bisectors PX, PY, and PZ are concurrent at point P. So the distance from A to P, B to P, and C to P are all equal. PA is equal to PB is equal to PC. Make sure you have this picture down. So that distance from the vertex to your circumcenter is congruent. If you look at the different circumcenters, if you have an acute triangle, it's going to be in the center. If you have a right triangle, it's going to be on the hypotenuse. And if you have an obtuse triangle, your circumcenter is going to be outside your triangle. All right, so now we're going to peel ourselves away from perpendicular bisectors and just look at angle bisectors. So we're cutting our vertices in half with a line, and where those points cross is called the incenter of the triangle. So the distance from the perpendicular bisector to point P on each of these sides is, so from Z to P, from X to P, and from Y to P are all the same distances. But if you look, the distance from A to P, B to P, and C to P are different. So that's the difference between that and perpendicular bisectors. So when you have angle bisectors, it's in-center. Circumcenter is perpendicular bisectors. This is what an inscribed triangle, a circle that is inscribed in the triangle, looks like. So you take the in-center and open up like your compass from the in-center to Z and make a nice circle with the center at point P. And that circle is inscribed in the triangle. All right. So we're going to start out with this problem here. What are the coordinates of the circumcenter of the triangle with vertices at 2, 7? Now, here's your choice. You could do this on graph paper and get the answer right. Or you can try to make your own wonky graph and get it wrong. My suggestion is you do it on graph paper and get it right. So if you don't have graph paper now, I would definitely get some out. So here is, A is at 2, 7. B is at 10, 7. C is at 10, 3. And we make a triangle, so I'm going to get my ruler out and we're going to make nice straight lines. And I like doing stuff with the virtual tools. Come on down, Mr. Ruler. You and me. Going to have ourselves some fun here. Okay. So we're going to make a nice little triangle. With a nice straight line. Okay, so using our ruler to draw a straight line to make sure we have everything squared away. So a circumcenter is what? Is it the angle bisectors or is it the perpendicular bisectors? Circumcenter, y'all. All right, so if we use problem number 1 as our template for solving our example problem, we're going to find the midpoint for each of our line segments, and then find the line that's perpendicular. Given that point and the line, we're going to find a perpendicular line. That'll be fun. Okay. So the first thing we need to do is find the midpoints. So what is the point halfway between A and B? So if you take your x coordinates and add them together, and your y coordinates and add them together, and divide each of those items by 2, you get 6, 7. And if you look at it, yep, that right about makes sense. So between B and C, The midpoint between B and C is our x's added together, our y's added together, divided by 2. So right here is our midpoint at 10, 5, and then C and D, or C and A. Correct letters down. So we're going to add the x's together. Once again, this is the midpoint theorem. Add the y's together. And divide both of those by 2. 12 divided by 2 is 6. 7 plus 3 is 10 divided by 2. So this is 6 and 5. All right, so now we want the lines that are perpendicular, and that's pretty easy to do for line AB. Because line AB is horizontal, line perpendicular is going to go straight up and down from there. So it's going to go boom. It's going to go straight up and down. And same thing with this one on BC. BC is a vertical line, so the line perpendicular is horizontal. And then if we look at our picture, for right triangles, where is our circumcenter for a right triangle? On the hypotenuse. So we want the line that's perpendicular to line AC. I'm going to find the slope of line AC, and the perpendicular slope is going to be the negative reciprocal. So line AC, the slope is going to be 7 minus 3, 2 minus 10. 7 minus 3 is negative 4, 2 minus 10 is negative 8. 7 minus 3, positive 4, negative 1/2. So the perpendicular line is going to be the negative reciprocal of negative 1/2. So opposite of negative is positive. The reciprocal of 1/2 is 2. So the slope of this line is 2. So I'm going to go up 2 over 1, up 2 over 1. All right, so the coordinate of our circumcenter is at this midpoint 6, 5. I just did the perpendicular line. I knew it's a right triangle is going to be on that point, but I did a perpendicular line just to double check. All right, we have a more mathy example problem. We know that QN, the distance from this center point Q to N, is 5x plus 36. QM is 21x plus 51. What is QO? And in this case, I know that we are talking about angle bisectors. So I want, when I'm talking about angle bisectors, I want to look at my incenter of the triangle. The distance from the perpendicular line from your side to your incenter is the same. That's different from the perpendicular bisectors. So we can say that QN is congruent to QM. So we go 5x plus 36 equals 2x plus 51, and we solve. Subtract 2x from both sides. Subtract 36 from both sides. Divide by 3. X is equal to 5 is not our answer because it's asking what is Q0 or QO, and that's this distance here. He's going to be congruent, so I'm going to take my 5 and I'm going to plug him in. You can pick either one, but I'm going to plug him into QM. So 2 times 5 plus 51 is 10 plus 51, which is 61. That is my answer.